To solve a system of inequalities graphically, we look for points common to both graphs. This is accomplished by graphing each inequality and determining where the graphs overlap or intersect. Let's take a look at this example of this system of linear inequalities. They're asking us to graph x is greater than or equal to 3 on a plane. The associated equation would be x equal 3, which is a vertical line. We are including the line because it's greater than or equal to indicate the points of the line are included. We draw that vertical line as a solid line, and values that make this true will be on the right side of the line. We could pick a point to verify this. Next, since this is a system, we will also graph the second equation, whether by its intercepts or converting it into slope-intercept. Drawing the line, if you notice here, we have it as a dashed line since this boundary line is not included in our solution. This linear inequality is a less than but not equal to, so points in this line would not result in a true expression and therefore are not part of the solution. We'll shade the half-plane region of points that do satisfy this linear inequality with red, and that is the region that is above the line. The region that is purple is the solution set of the system, since the coordinates of those points make both inequalities true with that overlapping. We could pick a point from this region, test it into both linear inequalities as verification. Let's take a look at another example. Here we have a system of linear inequalities. Again, we graph each inequality by graphing its associated equation. In the first example, or first linear inequality, we graph our associated equation with a dashed line since it is not part of the solution set. We want values that make this true, and we'll indicate that with blue shading, which turns out with test value of the half plane above this boundary line. Repeating the procedure with the second linear inequality, we will graph the associated equation there. It also, the line is not part of the solution since it's just a greater than without the equality to indicate that the points of this line are not part of this solution. We use a dashed line, and shading the region of points that do satisfy this linear inequality, we'll use red, and we shade to the left of this line. Our solution to these two linear inequalities will be the intersection of these two solutions, which is indicated here in the purple region common to both of these linear inequalities. Any point picked from this lavender or purple colored region will satisfy both linear inequalities.